Hello, everyone, and welcome to our fifth class. Today, I'm going to be talking about some OOP, or you can say object-oriented programming. This is um, a key idea among all coding languages, and it's specifically important in Java and C++. They have more objects involved in them. As for Python, we don't mention the idea of objects or classes that much, but it's still good to know. All right. So, wait, actually, before we begin, last time we talked about modules and then some applications we can do with modules and functions. Any questions? During the 7 days, you did any thought process?
Module and what?
We talk about modules and some applications of it. Any questions you guys got?
Not really.
All right.
Because I did a little bit of research.
Oh, actually, let me share this with you guys.
Doc?
Mm-hmm. There you go. All right. So let's move on to our some big picture ideas. First, we have the definition of classes. We talk about modules and they were files, right? And we can import them from outside.
Yes.
Well, it's the same thing for classes, or I should say very similar, because classes are just virtual files. So you can create a file inside a file.
Wait, so you're saying that the other thing is something that is in real life?
What?
So you said there's a difference in that one of them is a virtual and the other one you didn't really say anything?
No, I said it's like a virtual module, so a virtual file.
Okay, good.
Okay.
Yeah.
So files, inside files, you can have some variables. You can call them data types, or you can have functions. And same idea for classes. You can have its own variables and its own functions. And we have a more technical term for it. We call them fields and methods. But it doesn't really matter which one you decide to use. And when you create, or when you want to use the classes, I should say, you do the same way, or yeah, about the same way as you will want to import other modules or declare a variable. So let's take a look at some pre-made classes Python has provided us with its standard library, or just built in. You don't even have to import them. List is a perfect example of classes. there's a class called list inside Python somewhere. The interpreter knows. And when you want to use this list, you can go my list equals to 2 square brackets, indicating it's a list. This is like a special character that Python designed, so it has certain meanings. It's like when you call 911, you know that's police station, something like that. Or another way you can write it is just a list with a bracket. And that is that is similar, much more similar to what we're gonna see today. So you have the name of your class, and then you have a regular bracket after that. You may pass some parameters into that bracket, but that's not that important for now. So you see, it's the same way as you would initialize any other variables. You have variable name, whatever name you want to give it, and then use your name of your class and bracket. Boom, you got it. Whenever you want to access any data or functions from that class, that's exactly the same as you would do it from a module. You just use dot, indicating that something you're gonna write after the dot belongs to the previous one, right? So I can, for this one, I can say my list dot append. That means I want to add one more element at the end of my list. Right, that's built in, and you can access it. Right, so any questions so far?
No.
Any other people? We have roughly 21 in the meeting right now. You guys don't have to talk. You can use your chat, just type. Really? We're all good? All right. Let's move on. So I said it's very similar to modules, right? But I didn't say they're exactly the same. And here's why. When you use a regular module, and when you write a function for it, you simply don't have to write anything in the bracket declaration of your function if you don't want to, right?
Yeah.
However, when you try to write a function for a class, so if you try to write a method, then you need to have self as your beginning argument, regardless whether you want to have any arguments in the first place.
What does self do? Oh, it's indicating the object itself. Okay.
Yes, it's in the slides. And so what self, and remember in the, I think, third class when we talk about functions, I told you guys that you need to provide a argument. If you do not give it a default value, you need to have a value for it when you use that function. And you may have the question, why do I not need to provide a value for it now? Well, the answer is, how do we know when to use self? You always need to include self in your declaration of the functions or the methods. Sorry, like always put it at the first. And what this does is it's like uh, it's like another special character or combination Python gives. So it tells you, no, it tells the environment that you're indicating to your instance. Remember, instance, they're just objects.
Yeah.
Okay, you create an object to use classes. You can say create an instance. So let's say I have a class called my class. And here I simply create an instance, or you can say I create an object for that class. So I can use some of its functions. And when I do my object dot method, I'm trying to use the function that belong to this class. I provided argument 1, argument 2, okay? But I didn't do anything about self. And later, this method is converted into my class dot method, okay? Then my object arg1, arg2. Let me make this smaller so you guys can see better. Now, if you look back at the declaration, you will see my object is actually the name of this instance that I gave. And my class is the name of the bigger picture, okay? The name of the class that I'm having an instance for. So in the end, this function does not belong to my object. It belongs to the bigger picture. It belongs to the class. So now it's a class actually using this method now. You can think of this as a portal, okay? Whenever you use a function from a instance, you're entering a portal that will translate this into the class and using the method. But how does it know that which instance is calling this function? Well, that's what self does. Self indicates to the class that, okay, here is my instance 1, okay? My object is trying to interact with you, okay? The instance is called my object, and that here I have a couple arguments.
Okay.
And some of you guys may ask again, okay, why do I need to know which instance is using this function? If they're just like a tree and I have a beginning point and I have a couple branches, why does it matter that which branch is interacting with me? Well, sometimes it doesn't, but most of the time you have some custom variables that you have among the object. What is an argument in code? I want to hear for first. We talk about argument in class 3, I believe. It's about functions. Or you can think of it as parameters. Okay, so I said, where was I? Yeah, about the tree. So let's say we have two objects, right? They're both using the same function. And let's imagine we don't have the arg1, arg2. And one object, it has a variable, has a name saying 1. The second object has a variable. It's a private variable, okay? Belongs to the object itself. It's having a name of 2. And you're now trying to do a print, trying to print out their name. If you don't know that which instance you're actually talking about, then there's no way for you to print out that that value exactly. You know, it's going to be messed up. So that's why we need this self to tell the program, okay, where we are. I believe that it's going to be very vague, and most of you guys may not understand it. So here I am. Let's look at some examples. Let's say I have a class called person.
Can you enlarge the font?
Right, I forgot to do that every time. So I have a class called person. What it has is always include self, right? But actually, we don't need to go this far yet. Just say hi. You always need to include self. And we're simply gonna just print hello. Now, when we try to use a module from outside, we do import, right? We import some module name here, blah, blah, blah. Well, since we already have this class in our file, we don't need to do that for now. And all you need to do is p1 equals to person. Here, you just created a person. And let's see what's this person. It's saying the person is main.person object. So we're running this program and we're in main. For the ones that remember from last class, there is a thing called name equals to main. So this tells you that are you running this program by yourself, or are you using it as a external module?
Mhm.
And main tells us, well, we are running a standalone, so by ourselves. And we have dot person. So this person belongs to our current project or program, which is oop.py. All right, so now we know our object is called person, or the class is called person. And same as all other objects, use a dot to access its children's, or its variables and functions. And notice how I have a self here, but I don't have anything here. It's because Python will just automatically translate into this kind of format. And when I try to run it now, it's going to say hello. So this is a basic way of writing a class. You may find it very, very, very similar to a module. The only difference is you don't have this class when you write a module, and you just import this file from another file, and you do it like that. And since we already talked about how to access the content in another file, let's try it out. So let's do it. So if I simply have another function, attention, and this function belongs to my entire file. It does not belong to this class anymore. And this is gonna say, okay, that's all it does. And here I try to import my okay. The way we just want to use the hello is just op dot hello, right? That's all we do. And that will give us a single printout. That gives us a single printout saying, okay, it just imported me, right? Now, how do I access this class? Well, what is the thing that you're using right now? Can I that? Yeah, it's in our first class. It's called Visual Studio Code. I have a instruction of installation on the first class slide. Do you have it?
Wait, can you go back to ook.py?
I just have a function and a class.
Okay, I'm trying to.
Oh, no. Okay. There might be other people. They're also trying to follow what I'm doing. Don't. Just look
Okay.
at the screen, understand it, and then you can practice yourself. But for now, just focus on the learning part. Like I said before, that this dot is very important. It kind of tells Python the hierarchy, right? You have a parent dot children. This is the way we do it. Whatever before the dot is the parent, whatever after the dot is the children. And so, can someone tell me what should I do to access this person class? Let me give you a hint. Inside this op.py, my class and my function, they're at the same hierarchy, so they're on the same level, right? And for me to access my function, I use OOP dot the function name. And if I want to access the class, what should I do? Okay, that's great. OOP dot person, exactly. However, if I simply run it like this, nothing will happen. Nothing happens because give me 1 second. Do you have documentation? This, all right. So since our person is a class, is not a single function, it does not perform any action by itself. So we have to assign it to some other variables, or a name of the variable at least. You can do another, like P1, or you can do P2 to separate them. Equals not person. And here we have P2 is a person class. Now it can perform, it's a person object. Now it can perform any regularly as if this P1 can do. So anything the P1 can do here, P2 can do here. So the only difference between accessing this class from another file is the way that you would initialize it. But after you initialize it, everything should be the same. So if I want to access my say hi function, I just simply do like this. Same way as I would do it in its regular file or in its native file. Now we have hello. Is that what we want? Yes, that's what we want. All right. Any questions? I'm not moving on if I don't have one question from you guys. Okay. Well, let's see. What's your question, Kale?
Yeah, could I just like take a quick look at yesterday's like the calculator thing from yesterday?
Uh,
Or
let's get back to that at the end, okay?
all right, yeah.
Because that's kind of long and it's not quite relevant to today's class. So Kiki, you said why did you type self in the bracket after say hi? Right. So this is essentially the reason. You can either look at the slide or I can explain it. Okay. So the keyword self, as I mentioned before, if you have a parameter inside the bracket when you declare a function, you need to provide a value when you try to use it. But in the case of self, it's an exception. You do not need to provide any value for it. And in fact, you should not provide any value for that argument. Because it's indicating to the object itself. So for example here, when I call up my function, let's get back here, much easier if they're in the same file. When I use the function say hi with my P1, what it actually does is it'll turn this into person.sayHi, then P1. So the interpreter of Python, when it tries to understand the code, it will translate this line number 9 into line number 10. Okay, person.sayHi, P1. This self is embedded inside, so you don't actually get to see it other than writing it here. It tells the program, or the entire Python interpreter, that I'm calling this function from this P1 instance. Okay, that's all it does. It tells the interpreter that from where am I using this function? Okay, from where am I accessing this function? So think of it like your voice box, voice mail, like the thing you have in your phone that automatically answers it, or when you are not answering the call. You put that here, so think of that as self, right? Whenever others calls you and you're not answering, it just pop up automatically, tells the caller that your name and when should you call back, they can reach you. It's the same idea here. It tells the program that from who the guy is calling from. Okay, in this case, it's from P1. So Kiki, I hope that answers your questions. If it does not, you can just type in the chat or use your mic and just let me know, right? So what happens if we don't have self? Well, the short answer is it's going to crash. But if you do not believe the short answer and you want to try for yourself, here it is. It's crashing. You have to include self in the when you write a method for the class. But if you're writing a function that is not in a class, then sure, you don't need the self. I sent a link at the beginning of today's class. It's right here. Let me think. Wait, there is one exception where you don't need self, but then you need CRS indicating its class. It's called class methods. I'll see if we have time. I'll cover that in today's lesson. But for now, just remember, always include self. Technically speaking, you can, but just for the sake of it, I'm gonna say no, you cannot. This is like 911 again. When we call 911, we know we're calling the police station. Is it possible that somehow you have another number you can dial that gives you the police station? Yes, there might be, but I don't think it's gonna happen. Same thing here. Can you change the keyword from self to other things? Sure. It's just a name for the variable. As long as everybody in the world agrees, or even the language of Python agrees, then sure, you can do that. But I don't see it happening, so I'll give it that question a no. Just remember, self indicates to the object itself. That's all you gotta remember. All right, so here we'll write our first class ever. We just did that. And here it is, how you write a class. It's a couple of stuff you gotta remember. Use the keyword class, have a colon, then write your functions like normal with the self. And here comes to the variables. So before, we just discussed about how to perform some functionalities of the class. How do we write a method? But as we know that there are both variables and methods in a regular module or a regular Python file, you can say .py file. And same thing applies to classes. And there are two types of variables you can write or you can have. One's called class variable, one's called object variable. Just from its name, you can probably tell that class variable belongs to the class and object variable belongs to the object. Well, yes, that's in the end, that's how it is, right? But what difference does it make? Well, for class variables, since it belongs to the entire class, it means whenever you change the value of that class variable from one instance or from one object, then when you try to access that value again from another object or another instance, your value will be changed as well. So let's think of it like this. You have two people in you have two people in grade 1, right? And they both belong to the grade of 2020. So next year in 2021, they have a variable called their grade, right? So this year it's called grade 1. Next year it's going to be grade 2. And once you change it for one person 1, then it's going to be changed for person 2 as well, because they are moving up in the grade at the same time. And let's see. So I have student, right? I have a class named student. And I have a class variable called their grade equals to 1. So they're all grade 1 now. And actually, no. I'll just do the regular way. Get. So I'm trying to get their grades now. And now I'm trying to access the grade. It's a getter. We call them a getter. So S1, student number 1. And let's see what grade is he in right now. Then we have student number 2. And they're both in grade 1 for now. And in the next year, they're gonna end up leveling up, right? Their grade is going to go up by 1. So I have +1. And let's see what's their new grade now. Notice here, I only changed the grade, or not +1, or like new year. I only changed their grade from my S1. So I didn't do anything for S2, right? I'm only trying to get the grade. I'm not changing anything here, no nothing. I'm only trying to print out its value for S2. But somehow, both of the values changed. They're both 2 now. And that's a class variable. So whenever you change it from one position or in one spot, then whenever you try to reach the value again from another object, it's going to be changed as well. Because I said plus equals to 1. Well, no. Let me show you why. We can do something like this. Actually, let me get back to you after we finish the object variable. So in object variables, as mentioned in the name, that they're all belong to the instance independently. So it has nothing to do with the entire class. It doesn't care what happens outside of it, right? So whenever you change the value from one object, it's going to only affect that singular object, and that's it. So another object, it has the same variable that has the same name. It doesn't matter to them, right? They don't care. They don't care any change you made by yourself. Like you're changing your name. So two friends are sitting here, and one told the other one, "Okay, I changed my name from Sam to Tom." Well, the other guy is like, "Cool, all right, I'm not changing my name." Right? It doesn't matter to them. Same idea here. So Alex, you said the reason why S2 is changing as well is because I said plus equals to 1. Not quite. So in new year, it's still solved out. It's still plus equals to 1, but this time only S1 is going to be 2. S2 remained 1 because I used a object variable. Until this point, I'm only trying to show you guys the ideology of the class variable and object variable. And what you need to remember is when you try to access a class variable, since it belongs to the class, you have to use the name of the class, then the variable name. Then you use the dot, right? The hierarchy thing. You have to use this dot, then the variable name. This is the same, but the difference is you use your class name instead of the keyword self. As we mentioned before, self indicates it just reference to your instance. So it tells it's an object. Or using self, it tells the program that I'm using this variable from myself, from the object myself. And when you use class name.variable, you're telling the program that, okay, I'm using this variable across the entire class. So across all instances of my class. Yes, you can have class function and object function. The regular def I have here that include self, those are called object function because the self indicates to the instance itself. And when you want to use a class function, you do something like this, add class method. Then use def Um, oh, instead of self, you have CLS here. That's how you write a class method. So I can say hi here. And in fact, oh, no, you have class here. No, CLS, yeah. Wait, let me show you guys a everything combined together. How about that? So this time, I want you guys to, can we have class init? You mean this def init? This one? It's in this initialization code. What do you mean class init? Like a class has the name of init?
Yes. Just like add class method, then we define a initial method, and we don't have self there. We put class there to initial the class variables.
No, you see the initialization code only take place when you create a new instance of that class. So for example, if I do something like this, all right, before I do something like this, what should print out? It's going to be 1121. Actually, I'm not even doing the 2, just I'm only printing out the current grade that the students are in. That's all I'm doing. But when I have the init method, it's going to occur before I even use the get grade, right? So it's actually called up whenever I use this line of my code. And there is much more you can pass in. You can even pass in some custom variables here. You can say, all right, I want the grade of my instance or my object to be customizable. So S1 will be grade 1, S2 will be grade 2. You can do something like init. And you can pass in this value. Notice how I have the same variable name, grade and grade? It's fine because I use the keyword self. This self indicates I'm interacting with a object variable here. Well, this grade here is only a local variable, or a passed-in parameter, I should say. So whenever we try to initialize this, init 1, init 2, it only happens when we try to initialize the code. It's the same idea as the main functions that we saw last time in modules. Remember the main functions? They only occur when you use the module for the first time and the only time. Same thing here. It only occurs when you try to initialize this object, and that's the only time it's going to occur. It never happen again. Okay, this init function is never used again by this object. What I'm trying to do here, I'm just showing you guys some the difference between class variable and object variables, and the init method, which was supposed to be our last. Wait, where did my? Oh, it should be here. Why did I skip that? Oh, yeah. So we just talk about the difference between the two type of variables you can have in the object and some initialization code you can do, or how to do them. So we're 1 hour into the class. We're gonna take a 10 minutes break. And after the break, we're gonna come back, and since we have some time, we'll go through the inheritance, and I'll cover the class method as a bonus.
Okay.
Why is nobody talking?
Because it's break time.
I know, but shouldn't we be talking just a little bit?
I don't know. Last time someone got in trouble with their dad because they were talking about Fortnite.
If I was her dad, I would just smack this. Sorry, I said too much. All right, well, I'm
You
getting
should use fake sensors. They're pretty cringy and annoying. My advice. Okay, so what do you want to talk about during this break then?
Why did he get in trouble for talking about Fortnite? It was break time.
Probably because it was coding and his dad doesn't ever understand. Because
His dad just doesn't understand that it was a break time.
Yeah, because he's a boomer.
Boomer. But if he was a boomer, how would he know that Fortnite exists? Illuminati confirmed.
Because, well, he thinks, well, actually, he wouldn't really be a boomer because he knows that Fortnite is bad.
Yeah.
Fortnite is also cringy.
He's half boomer, half millennial.
Okay, yeah, hold on. I'm gonna get something.
Oh, Alec, are you actually the host right now? Oh, never mind. You weren't. Does anybody here play Apex Legends? By any chance?
Okay, I'm back. Okay, there's a big fuss downstairs because someone got bit by a mosquito.
Bruh. It's just a freaking mosquito.
Huh?
Hey, Alec, how old are you?
Why would you want to know? Fine, I'm 11.
I don't know. I just want to see the average majority of this class, how old they are, basically.
Okay, how old are you then?
I'm 11.
Okay. So you're in grade 6? Are you in grade 6 or in grade 5? I'm in grade 6.
I'm going into grade 6.
I'm going into grade 7.
Oh, cool.
Oh, that's because I'm in 2008. Or probably 2009.
I was born in 2009.
Okay, yeah, I was born in 2008. That's why I started school earlier than you. Were you born in January or something?
What?
Were you born in January or something?
No, I was born in. Well, I consider myself 11 because it's like next Monday is my literal birthday.
Oh. I was born December 29th.
So it's literally 4 days after Christmas.
Yes. That also means I don't get extra gifts.
Ooh.
I know, it sucks.
Yeah. Alright, so you like I Alright,
Or
I'm
continue.
not exactly Christian, but I do sometimes go to church because I was forced to. But I know that. Alright, so
Wait,
Jesus,
so your parents are Christian, but you aren't.
yeah, basically.
So they're not. So they're gonna freak out if you're LGBTQ.
Of
No, not just freak out. They're gonna whip you.
No, not necessarily.
They'll just be upset.
They'll be like, "Well, you."
Okay. Dead memes are also.
Oof, I'm sorry.
Just listen to the song. It's way better than actually saying it.
Oh my God, yeah.
So you know how Jesus was born on Christmas. So
He's literally why Christmas was created.
yeah, there was literally like think of it
Open.
like, oh god, like, he didn't have a Christmas present, he just had his birthday present. It's literally the same as you get one present in the entire year.
Except that you can't debate about it.
Yeah.
Like, I could say that my birthday is not on Christmas, but Jesus really has no way out of it.
Yeah, it was like, God, no. Like, it was literally named after him. Chris.
Okay, yeah, it's time.
Voice, it's time.
Dang it.
Okay. Right, so we finish off with the variables. Now let's look at some inheritance. Okay, do any of you guys remember that why we should divide a long file into a couple smaller files and make them into a module and use import as the glue to glue them together? Do any of you guys remember why? Or can think of why? Yes, to make it clear. And there's one more. One more reason. And that is to reuse the code. It's the same thing as why we should use functions instead of just write the code there, like every single time we want to use it. Everybody in the same hierarchy would just go from top to bottom. We don't want that because we want to reuse some of the code. Same thing with hierarchy. With inheritance, you're able to use the code over and over and over again. For example, here we have school member and student. Well, we all know that student is part of the school, so whatever characteristics the school member has, our student must have. Then we can simply just inherit our school member from the student. This way we get all the functions, all the methods, all the variables that the school member already has. And then we can make some adjustment based on our needs, or we can simply just use them. In this case, we call the one that is importing from others, in this case the student, as the subclass, and whatever is importing to, we call that the superclass. In this case, it's the school member. So when we want to use inheritance, we have a superclass, and if we want to include that superclass in some other smaller classes, we call those smaller classes subclass because they use the superclass in them. So let me show you guys an example. Yes, yeah, that's basically why that we use inheritance. So, I have one thing called your name, right? For each member in the school, they all have a name, right? It doesn't matter if you're a teacher, you're a guidance counselor, or you're a regular student, you'll have a name. And here it is. Other than name, we have other things we can have, like age, your height or your weight, anything. For now, I'm just going to list one. So it's simple. And here we have some student. Okay, notice how here I don't have anything after my school member. I don't have a bracket or anything. But if I want to use inheritance, then I need to have a bracket behind my class name. And inside the bracket, you put in the name of the class that you want to, or the name of the superclass you want this subclass to inherit from. In this case, it'll be school member. And of course, in every single class, you should always have an init method. Even though you do not initialize anything, I still recommend you to have one, just in case you want to put something down and you know where it should go. Of course, we have name, and we can have grade. Okay, so can we just go like self dot name equals to name and self dot grade equals to grade? But this way, I have both my name and my grade in it. But you just create a new student called s1 equals to student. And let's run that. Oh, All right. So here we have a student, and it's me. And we want to print some of its features. We can simply do like that. And this works 100%. But is this good? Did we use this school member at all here? Did we? No, we did not. And that is not what we're looking for, right? If we inherit a class from outside, then we for sure want to use it, okay? And since it already has the name, well, in this case, it is much easier if we just use the regular self dot here. But imagine if you have 1,000, not even 1,000, 10, okay, 10 or 11, like you have a bit more parameters here. You don't have to type them over and over again. You can just call the initializer inside your student class. And you have to do them right at the beginning. The school member. Wait, was it like this? Yeah. Student. Why is that? Okay, give me 1 minute. All right, okay. So it turns out if you want to do the initializer from a subclass, you need to use the name of the superclass you want to use and dot init. And here you have to pass in self, because you need to, since you did not create any object of this class yet, and you want to tell it, do not create a new one, use the pre-existing one that I have right here for you. Okay, and let's try this. And you can see I created a new school member right here, and then I create a new student. And some of you may ask, well, is it possible for me to initialize my superclass at the end of my subclass initializer? Well, I don't think it's gonna work, but it did work. So I guess it's fine that way too. All right. And there's one thing you should look at. I have two functions. They both have the same name, toString. But the first one begins with my name is blah, blah, blah. The second one is the name, then is in what grade. Which one actually got printed out for here? It's the second one. All right. So inside the student member is the newer one that's actually usable. And that is because there's a thing called override. In Java, you need to write something like add override here. Well, in Python, you should not do it, but the idea are the same. You are overriding a pre-existing function from your superclass. That's basically what you're doing here.
Mm-hmm.
So we can do the same thing if we have a teacher class. And we want teacher to have their subject and their, right. I want to initialize that as a school member.
Located in a serene, rich neighborhood in Argentina's capital, the prestigious bank contained a fortune in its vaults. Police officers arrived at the scene and discovered that 4 thieves and 23 hostages were inside. They secured the perimeter, guarding the only 2 possible exits from the bank.
And we can have another toString method that's going to print out its features.
At 7 p.m., police officers broke into Banco Rio and found a confounding scene. The hostages were alive and well.
Well, why do I hear the news in the background? Whoever that is, can you turn your mic off for now?
Were broken and the exits had been watched by police the whole time. How did these thieves get away with what's become known as the robbery of the century? How did they disappear under the careful watch of more than one?
All right, much better. So if we have functions that have the same name across different classes, it's always going to use the one that is written on the lowest level or the highest, depending on how you understand it. So it's always going to be the one that's in the subclass or the subclass of the subclass of the subclass. So whichever one is the closest, it's going to use that. Like that. Oh. However, if I do not have a toString function, so if I do not override a pre-existing function, then it's going to search up in the hierarchy until it finds a function that has the same name. So if I comment out the toString function in the student class, it's going to use the toString function from my school member class. It's only going to print out the name, but it will not say anything about the grade. Yes, you can inherit multiple classes. It's definitely doable. So let's give that a try. If we want to inherit multiple classes, subclass.init won't call superclass. No. So for the init methods, in Java, it is required to have the superclass initialization code in your subclass initialization or main function. However, in Python, it seems like it doesn't require anything like that. You can just import a class and not use it at all, and that's perfectly fine for Python. But I mean, what's the point if you're not going to use it, right? Then just don't even need to inherit it. But whenever you do want to initialize a superclass, you have to use the name of the superclass .init, then bracket, like this kind of format. And this is, I think, one of the only time you pass self in as a parameter when you use a function. Like you actually write self when you use it, not when you initialize it. This might be the only time. Actually, let's change something based on this. Let's have another class called human, shall we? Well, as a human being, we simply have one thing called age, and that's all we're gonna do for now. And if we want to make student a human, of course it's a human. So let's pass that in. Then we should add an age in the end and initialize it. And in our toString function, is not only in some grade, but we also want to print out its age. Let's see how that goes. So age 17, there we go. If we call toString method in the which superclass? Well, okay, so you're saying if I have a toString function here, which one will be called? Well, it depends on which one you want to use. If you use human.toString, then it's going to use the toString function from the human. Or if you want to use, well, let's use both. So inside our toString function from the student class, we want to print out for our school member, our human, then our own toString function. So first we have a school member, right? Where it's saying, okay, my name is George, my name is blah, blah, blah. Well, that does the job. Then here comes a human. My name is 17. And then they combine them together in the student, a toString function. George is in grade 12, age 17. So you can choose to use which one of the function that has the same name for your from your superclass. Just depends on which one you specify, that's the one it's going to use. Okay, so you're saying, what if you don't have this toString? Well, I've never tried it before. Let's see. Okay, so it ended up using the school member one. Well, I'm kind of curious. I don't know. Is it because I initialize the school member first? Well, let's reverse the order. No, it's still using the school member one. What if I put it behind afterwards? Yeah, okay. I think it has to do with the order of your inheritance. So it doesn't matter which one you initialize first. It matters in this bracket which one you put at the beginning. So I think the hierarchy goes first, second, then third, fourth, on and on. Whichever one is at the front, it has a higher hierarchy. So in this case, toString, it'll be caught up for human if I put human before school member. It's going to have my age is 17. But if I do it the other way around, it's going to consider school member a higher hierarchy. So the toString function will be from that class.
Can you scroll to the top?
Here. So Jonathan, does that answer your question? All right. So that's it for the inheritance. And as I promised, we're gonna have a little extension about some class. Let's talk about some class and method. And there's a little extension to that called static methods. I'm gonna make another reference to Java. There are 3 type of functions: private, public, and static. Oh, unfortunately, in Python, we don't have any private functions. Or luckily, I don't know. I think private functions is a good thing, but it depends on, differs from person to person. But we only have public functions in Python. However, we do have static methods and class methods. The functions in a very similar way as in Java. So again, let's use student as an example. This time I'm not going to inherit anything. I have an initializer. I have my name. Oh, wait, actually, I know something pretty cool. Robot. Let's have a robot. Let's build a robot. Okay, robot count. At beginning, this is how you write a class variable. So if you just put it in the class directly, it's a class variable automatically. You don't have to do the class name dot variable name. No, that's if you were writing that in a method. If you're just writing it like this in the initialization part, it'll consider that as a class variable. And we have our initialization. We want to name our robot, okay? We want to initialize our robot. And we want to give our robot a custom name. Later on, we want a class function or a class method. And instead of self, you have to have CLS, standing for class. And all we're gonna do is try to get the, oh no, CLS goes in here. The robot count. So how many robots do we have right now?
You have 0 robots.
Well, for now, okay, for now. But that's not what we are gonna care about. We want to print our robot count. So how many robots do we have? And we want to have a static function or a static method. That is going to just say, or greetings, right? It's just going to say, okay, hello, this, I am a robot class. That's all it does. It doesn't even take in the CLS. I'll explain the difference in a minute. Oh, and whenever you create a new robot, we want the robot robot count, because we want to change the value of a class variable. All right. So actually, one more. Let's do one more function. Now, we want to have a first robot called C3PO. This is our first robot. I want to give it a name. Okay, C3PO. And we want to have another robot called R2D2. And at the very beginning, let's see how many robots do we have. So get robot count. Since we're using a class method, we don't have to have a object. We don't need an object to use this function. We simply can do something like this, right? But now we're gonna create one robot, and we're gonna see how many robots do we have for now. And then we're gonna check it again. And let's do this static function here. Okay, so first of all, we use this static method, and all it does is to print out a simple printout line. Then we try to figure out how many robots do we have now. 0. Then we initialize the robot. Well, let's bring in the name. We first initialize the C3PO, then we initialize the R2D2. And our amount of robots changed. However, I did not access this robot count from any of my objects, but I access it from my class. And that's what a class method does. It can have access to all the class level variables and variables. For example, here, robot count is one of those. But if you ever decide to go so far and reach can we have static? If you ever decide to go so far and print out certain features from your objects, like your name, then that's not doable. You can't do something like crs.name because that doesn't exist, right? You can't do something like self.name because you don't have self. You did not passing anything here, okay? It is not an object, it's only a class. You deal with whatever you have on the class level. And that's a class method. But sometimes you don't even want to deal with the class level variables. You just want some functions that can do a simple job, like a simple printout to tell the user that this is a robot class. Then you can use a static method. Since you don't even pass anything here, you can pass in some arguments and make this into a functional method. It can do addition, subtraction, like the calculator we did last time. It can do something like that, but nothing to interact with the outside. So if you have a static method, it's basically just a simple function that you have. It doesn't even have to be in the class. It can be a function just outside of the class. I can write this function like here, and it won't make any difference. They do exactly the same thing. Just print out a single line. But if I do my function here, I try to get the robot count, that won't work because I don't have the CRS. I don't have the class. I cannot interact with it, right? Does that make sense? It might be kind of confusing. I'm just going to summarize it. So for your regular object methods, they interact with everything, right? Including class and object variables. And then you have your class methods. They are a bit special. They only interact with class variables. And then at the end, you have your static methods that don't have any access to the class or objects, okay? They are pure functional methods. They don't interact with anyone. Well, you can for sure pass in some parameters here, right? Like number. And here is my number. You're gonna do something like this. And it's going to take in those parameters and print it out, but it doesn't do anything with the class or the objects. It's a pure function like the ones that we have dealt before. You know, it's just a pure function, nothing related to the outside world. Can you have a static class variable? What do you mean a static class variable? A class variable is it belongs to the class, right? If you want to have any variables, it's either belong to the class or it belongs to the object. It cannot have some variable that doesn't belong to either of those because it has to be within the class. So in Python, this static doesn't make any sense, so no. But static in Java, it means a different thing. Static in Java actually means class in Python. So in that sense, you can have a static variable, but that's in Java. In Python, no. Right, that's the class methods and the static methods. Questions? I'm expecting, let's see, how many people we have? 20. Okay, I'll take 3 questions before we finish our class today. So if you guys want to leave early, ask questions. Do we have many init function? You mean can we have many init function?
Is there a replacement for an init function?
No, it's the only thing you can do.
Okay.
Again, in Python, no, I don't think in Python it allows any function with the same name. But in Java, the initializers, they're called, there's a special name, constructors. They're called constructors, I'm pretty sure. And you can have multiple constructors that they perform different functionalities depending on how many arguments you pass in. But as for Python, no. How about the question I asked earlier? What's your question you asked earlier?
Sorry?
Kale,
Can you say that again? Sorry, I didn't hear. Sorry.
what's the question that you asked earlier?
Oh yeah, I was having trouble with like yesterday's thing, so like could I just like see it one more time or
Oh, the calculators?
yeah.
It's kind of long. I don't think it fits in one page. Let me change the font.
Wait, because there's like another one where you import it in, right?
Right, yeah. Oh, like this one? Where I imported it. Is class? No, Derek. I said I will end the class the earliest after I receive 3 questions. So what does toString mean? Okay, that's a habit I carried on from Java. It just means print out some of your characteristics your class has. You can change it to anything. So for example here, instead of using toString to print out that my name is blah 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 for the robot, you can change it to, well, my name. You can change it to something like that, right? It doesn't matter. It's just a name for the function. But normally when you see toString in a class, it means to print out its personalities that class has. So some of its variables and some other settings like that. For initialization, can we use possible share this Py file? Yeah, I can share this .py files with you guys. Yeah, the custom length variables, single star, double star, both works. You can have either of those for your init functions. But you have to remember that if you choose to use those custom length variables, then they're all assigned under one name. So if you have something like, I'll just do it here. robot might have some hobbies, right? Then this hobby become a list, and whenever you want to access that certain thing from that hobby, you have to do hobby with its index. Or it might be something like your score. So you might have some different scores depending on your games. So game 1 you probably have 10 score, like game 2 like that, and then you have to treat them as a dictionary. So score with this key. So that's how you're gonna access those. And they will all be put under one single name. So be careful with that. All right. You guys all got some great questions. And that's it for today. We talk about some classes, objects. It's been a long 2 hours, and I hope you guys can go over the slides at home. Are you already at home by yourself?
Okay.
I'm going to do next class. I'll probably go through some data structures and file IO. Yeah. So file IO and dictionary and set. And I'll maybe do a small review of list. Yeah. Oh, and yeah, that's it for today's class. Kale, if you're still here, what's your question about the calculators?
I think I did it like a little bit differently from you. But when I tried to import it, and then use it in like a different file, it said that add was not defined, but in like the first file, it was.
What?
So like the file with like the actual calculator code, like add was definitely like defined, right? It's like define add something plus something a b return a plus b, right?
Yeah.
And so when I tried to import the calculator, it didn't work. It said add was not defined.
Right, you gotta show me your screen.
Okay.
Yeah, I'll
I cannot
try
show
really
my
hard to
screen.
remember sending the recordings. Yeah, I'll put that on my to-do list. Slides of last class. Weren't you here last class?
I was here last.
No, it's about Kiki. Yes.
Oh.
Oh, you weren't? Okay. It's fine. Right. Have you shared your screen yet?
You disabled screen share for participants.
Oh, yeah. There we go. try it out. You should be able to do it. Yeah. You have to make it into a string.
Sorry?
Put a single quote around the ad. Yeah. That should work now.
Like this?
Yeah. Yeah.
Oh.
I don't know why it's saying invalid though. You gotta show me your calculator file. Okay. When I say about type, I mean a type in string format, right? You don't pass something like add, because add in this sense it's a function. But when we do comparisons and try to figure out what exactly the action you want to perform, we're talking about strings. So put a single quote around your add, sub, multi, and div.
like here or
Yeah. Here, down below, with the double quote. Yeah, put a single quote around it. Same thing apply for sub, multi, and div.
Wait, do I do it here or no?
No. Those are your functions. So when you use your functions, don't do it. But when you try to do a comparison between strings, then yeah, you need to do it.
And so then it would theoretically work here.
You have to save your calculator. Yeah. Control S. Control S. Yeah.
Wait.
Now run it.
Alright, I think it seems to be working.
Why is it saying invalid? Can you go back to your calculator?
Yeah.
What? Can you do a print under the if type equals to add? Yeah, add a print.
Wait, instead of
No, just add a line. Don't delete anything. Just add one more line. Yes.
and add what?
Press tab first. Yeah, print just hi. Print hi. It's for debug. Yeah.
And then try it here.
Save the calculator first.
Wait. This is invalid.
Can you go back to calculator?
Yeah.
Oh, it's because you have line 29.
Oh.
Yeah. And you see how that add, you don't have the quote around that? It's
yeah.
Control Z, Control Z. Control Z again. Yeah. You see how you don't have the quote around the add? That's why it's giving you an error.
So,
yeah.
Thank
Either
you.
delete that or add a quote around it and you're good to go.
Alright, thank you very much.
No problem. Any more questions? Yeah, you might want a proper name, a better name next time. No? All right. That's it for today's meeting. And have a good night, boys. I'll see you next week.